Here's a particular problem that will allow us to review the calculation of molar solubility, and we want to put these in order of least soluble to most soluble. Here we have two compounds that have the same number of ions, and both being 2, this one then having 3 and this one having 4. So the best way to categorize these compounds from least soluble to most soluble is to solve for the molar solubility value. We can do this again by expressing each of these concentrations as the molar solubility. For copper 1 iodide, we know KSP is going to be equal to the product of copper concentration multiplied by iodide concentration. And because the stoichiometry is 1 to 1, the molar solubility will be equal to the copper concentration, as will it be equal to the iodide concentration. So the KSP expression is simply KSP is equal to S squared. To solve for the molar solubility, we'll take the square root of KSP. Turns out we end up doing the exact same thing with silver iodide. KSP will be equal to molar solubility squared, and molar solubility will be equal to the square root of KSP. For the other ones, things are a little different, because in this case, KSP is equal to lead concentration multiplied by the iodide concentration squared. So the lead concentration is equal to molar solubility, but because we have 2 iodides, then every time one of these dissolves we get 2 iodides, so the iodide concentration is actually equal to 2 times the molar solubility. We then take these expressions, plug them into the KSP expression, lead concentration being equal to molar solubility, iodide concentration being equal to 2 times the molar solubility, and then we square it because it's in the KSP expression. We get 4s cubed, molar solubility then is equal to KSP divided by 4, and you take the cube root of that. And then for the last one, bismuth iodide, KSP is equal to bismuth concentration iodide cubed. Bismuth concentration is equal to molar solubility, but because there are 3 iodides, then iodide concentration is equal to 3 times the molar solubility. This then gives us KSP being equal to S multiplied by 3S cubed, the whole thing cubed, the 3 and the S. So we get 27s to the 4th. S is equal to KSP now divided by 27. You take the 4th root of that, and we have our molar solubility. So now we can directly compare molar solubilities to determine the one that is least soluble and the one that is most soluble. In looking at our molar solubility values, we will see that the silver iodide molar solubility, which is 1.2 times 10 to the negative 8, is the smallest of all, so it is the least soluble. If we're going from least soluble to most soluble, then it will be ranked number 1. Then we go to the copper iodide molar solubility, which is next in line, so it is 2. And then from 10 to the negative 6, 10 to the negative 5th is greater, so bismuth iodide then is 3rd, and the one that is most soluble has a molar solubility of 10 to the negative 3, that being lead 2 iodide.